Okay, fifth graders, we're on page 134 in your Bridges Math Workbook, and this page is titled More About Quarters. We're going to solve some number puzzles, and I'm going to read number 1, and then I'm going to remind you again about how to use number puzzles. Number 1, fill in the blanks to complete each of the box challenge puzzles below. Remember, the number at the top is the product of the two numbers in the middle, and the number at the bottom is the sum of the two numbers in the middle. So let me remind you about how to solve box challenge puzzles. So remember, left side times right side equals the top. Left times right equals the top. Left plus the right equals the bottom. So think of left plus right equals the bottom. Left times right equals the top. So let's go ahead and I'm going to remind you about how to think about quarters. As you're solving the box challenge puzzles, it's really important and helpful if you think about quarters. Here I have 4 quarters above this whiteboard. So think about 25 times 4 equals 100. You can think about this as 100 cents. You can also think about this as 0.25 times 4, which equals $1. $1 is the same as 100 cents. We can continue to think about multiples of quarters. So I know that it takes 4 quarters to make $1 or make 100 cents. So if I want to create $2, I just think about 0.25 times 8 quarters is going to equal $2. So if you imagine that I had 8 quarters on this whiteboard, I would have $2. I can also think about it another way. I can think about 25 times 8 equals 200 or 200 cents. So for our first box challenge puzzle, we have 25 times what equals 400. Or think about this as 25 cents times what number makes $4. So I have a little table right here I wanted to show you to help you solve these box challenge puzzles. So what we do is we have 4 quarters we know equals 100 cents. Then if I go to 6 quarters, that's actually 150 cents or $1.50. Then I have 8 quarters, it makes $2. And as you can see, I'm going by multiples of 2. 4, 6, 8, 10, 12 is $3. 14 quarters is $3.50 or 350 cents. And then finally, 25 times 16 equals 400 or $4. So my missing number will be 16. So 25 times 16 equals 400. Now remember, left times right equals the top number. Now to figure out the bottom, it should be 25 plus 16 equals 41. And I know that 25 plus 16 equals 41. Okay, let's focus on the box challenge below. Now this one is probably pretty easy. This is 0.25 times what equals 1. Remember to think about this as one whole dollar. So think about 25 cents times what makes $1. And then think once you have that missing number, you should be able to add the missing number to the 25 cents to get $4.25. Okay, for the next problem, we have 25 again. So 25 times what makes 250. It might help when you solve these problems to create a table like I did, and then you can continue to build your table by following the pattern. So instead of 16, I'm going to start with 18, and then I'm just going to follow the pattern. This is skip counting by 50s, if you noticed. And you can continue to follow this pattern to help you solve the box challenge puzzles. So right here, I know that 25 cents times, let's see, 10, 25 times 10 equals 250. So this missing number would be 10. Now I know that 10 plus 25 equals 35. Okay, so now your next job is to figure out 25 cents times 36 makes how much money. So you might want to just multiply these two amounts here, and then you'll be able to find the product, and then you can go ahead and add these two amounts here to get the bottom number. So the next problem is 25 cents times what makes 500. So think about this. How many quarters does it take to make 5 whole dollars? You can figure that out. You should be able to figure out the box challenge puzzle. And then the bottom puzzle here is 0.25 times what makes 15. You can think about this as $15. So how many quarters does it take to make $15? That should be your missing number. Then you're going to add your missing number to the 25 cents to get the $60.25. Now we're on question 2. Jamie is completing the following box challenge puzzle, and he says that the missing number on the right should be 100, and the missing number at the bottom should be 101/4. Do you agree or disagree? Explain why. So right here we notice that this is 25 cents and we have 1/4 right here. So think about 1/4 as 25 cents. So 25 cents times what number equals 25 cents? So once you have that missing number, you should add this and this together to get the bottom number. In this problem, Jamie says that it's 101/4. Do you agree with Jamie? Explain why or why not. One hint that I want to give you for this one is I want you to think about money. We've talked about money quite a bit this year. When we think of money, you can think about $1. $1 is called $1, or it's called 100 cents. So, do you agree with Jamie or do you not agree with Jamie? Go ahead. Okay, now we are on number 3. So in number 3, you have 4 problems. You're going to find the product, the answer in multiplication, or you're going to find the quotient, which is the answer in division. So what we're going to use is this is like think about this as a problem string. We're going to use the answers and the problems to help us figure out the answers in the rest of the problems. Problem A, it's 30 times 25. I'm going to use the standard algorithm, or what we say the classic way, to help me figure out the product. So I'm going to start with the ones place. 0 times 5 is 0. Now I'm going to start with the 3. 5 times 3 is 15. Now I'm all done with the 5, so I'm going to cross out this 5, and I'm going to put 0 as a placeholder below. Now I'm going to multiply the 2. 2 times 0 is 0. 3 times 2 is 6. Now I'm going to add, so 30 times 25 equals 750. I'm going to write that product down, and this is going to really help me solve the rest of the problems for B, C, and D. Okay, here comes the fun part. Now I figured out A, 750. So now I'm going to go to B. B is 750 divided by 25. I just noticed something. I noticed the 750, and there's the 750. I noticed the 25. There's the 25. So the missing quotient has to be, yes, if you said 30, you're absolutely correct. The missing quotient would be 30. 30 times 25 is 750, or 750 divided by 25 is 30. Okay, now you're going to try and solve C and D on your own using the products and the quotients above. What you're going to notice right away is this is 7,500. It looks a lot like this problem. There's only one little difference. And then this one's a little bit different, but I bet you can use your mathematical thinking and critical thinking skills to figure out the product. Okay, good luck. On page 135, you're going to find the product of each pair of numbers below. You can make a labeled sketch to help or just use numbers. Show all your work. So, fifth graders, you have two ways of solving this. You can use the standard algorithm, the classic way, or if you're more comfortable, you can use the area model or the box method to help you solve these problems. Okay, let's solve 35 times 23 using the classic way or the standard algorithm. You're going to see that I highlighted the 3 and the 2. Sometimes it helps if you think about multiplying the ones place first and then the tens place. This sort of helps you see how the problem is broken apart. So I'm going to start with the ones, or you can see the 3. So I'm going to start with 5 times 3 is 15. Just like addition, I have to carry the 1 to the next column. So 5 times 3 is 15. Now I'm still focused on the 3. So I'm now going to go 3 times 3 is 9. Don't forget to add the 1. So 3 times 3 is 9 plus 1 makes 10. I'm going to write 10 right here. Okay, I am all done with the yellow or the 3. I'm going to cross that out and I'm going to put a 0 below. I am all done with this 1 here. I'm not going to use that again. So I can cross it out, or erasing it makes it just disappear, makes it a little bit easier to see. Okay, now I am ready. Once I have that 0 as a placeholder, I am ready to focus on the green part, or the 2, the tens place. So I'm going to start with 2 times 5 is 10. So 10, I'm going to put the 0 and I'm going to regroup the 1 just like I do in addition. And then I'm going to multiply 2 times 3 is 6 plus that 1. 6 plus 1 is 7. There you go. Make sure when you're using the standard algorithm or the classic way, make sure your digits are lined up. We want digits stacked one on top of the other. And then I'm going to solve this. 5, 0, and then 8. 805. You can double check with a calculator if you are not sure. So now we're on page 136. This is your last page. Again, there is only 3 problems to do on this last page. So number 2, solve the story problems below. Make a labeled sketch to help, or just use numbers to show all your work. So students, once again, you are welcome to use the standard algorithm or the classic way, or you can use an area model, or we call the box method. Use whatever strategy you're more comfortable with. Okay, let's start with A. John works at T-Shirts R Us. Yesterday, he unpacked 36 boxes of new shirts. Each box had 24 shirts in it. How many shirts did he unpack? As you can see in the story problem, John unpacked boxes of T-shirts. He unpacked 36 boxes. Each of those boxes had 24 T-shirts. How many T-shirts did he unpack? So this sounds like a multiplication equation. Problem B. John made 24 stacks of long sleeve T-shirts. He put 18 shirts in each stack. How many shirts did he stack in all? So remember, a stack is like a pile. So imagine a pile of folded T-shirts. And he had 27 stacks or 27 piles. In each stack or pile, there were 18 T-shirts. Go ahead and use your strategy for double-digit multiplication to figure out the answer. Keep going, 5th graders. I am proud of you. Keep working hard.